Now, in this video, we will going to discuss about the building virtual product models. The 3D geometric modeling using CAD software allows engineers and designers to build realistic 3D computer models of parts and assemblies of products. So, the geometric modeling is the mathematical representation of an object's geometry using software technology. So, basically, this is used for creating the three-dimensional model wherein it's a solid model what we are talking about. The designer constructs a geometrical model based on the product specific features which include technical functionalities or production related details such as draft angles or fillets. So basically this geometrical model what we do or what we create, which will going to have specific features, and also it includes the technical functionalities or production related details. And even when we are talking about the production related details, which is like draft angles. See, basically the draft angles is the one which is going to be given for easy ejection when you are making in the manufacturing. And also the fillets, basically to reduce the stress concentration factor when it will going to be happen when it is sharp. There is always a possibility that there will going to be a crack. So in order to avoid that, all those things, these are the technical details which are going to be considered when we are going for the designing. That too, when you are trying to do it in geometrical modeling, we are going to create all these things. Then the geometry is built up through a combination of single components into an assembly structure. So that means you have single components put together from one component to the other. Basically, we create the solid models by individual parts, and then we go for the assembly environment, and then we are going to start doing the assembly of individual parts. The geometric models created by the designer can open at any time for reviewing, editing, or analysis. So the geometric model, the designer, once we create the geometric model, it can be used for reviewing. Suppose if you are today has done something, and tomorrow if you want to think that yes, we need to modify that, yes, you will go for that particular feature and we can modify those features and that particular model tree, and then which can be saved again. And then if you want to go for analysis, yes, we can do that also by importing the same 3D model into an analysis software. And this interfacing, what it is going to be considered is the IGS format. The geometric models created by the solid models can intersect, join, and subtract objects from one another to create the design parts. So basically, what does it mean? That it will going to adapt for the Boolean operations what we are going to be consider. The Boolean operations, in other words, it will going to be a union, and it can be a subtract or it can be an intersection. But basically we use joining, that is the adding, and the subtracting is the one which is going to be used much, but intersection is will going to have very much a limited application. So the solid models can intersect or it can be joined and subtract objects from another to create the design parts. And the SolidWorks, Unigraphics, NX, CATIA, etc. are the few modeling softwares used in today's industry. So basically the industries uses, each industry will going to have their own type of the solid modeling packages they will going to use. Some people will going to work with SolidWorks, and some people will going to work with Unigraphics. Some of them will going to work with NX, and some of them they may use CATIA, and some of them they may use Creo. But basically on mechanical desktop, all those things which will going to be used, but still AutoCAD Inventor will going to be used. Basically all these softwares will going to have the same characteristics, but only with minor changes it will going to be takes place. Therefore, a student who is going to be completing his engineering should have the basic knowledge of all these types of this, all these solid modeling packages. If you have only one package as a whole, but the application wise all the softwares will going to behave in the same manner. So if you learn one software thoroughly, then we can use the application of other software will going to become just a matter of time. So that is how this modeling will going to work. This is the basically it's in solid modeling. So today's industry is looking at only these types of software, and we can learn any one of them. The various techniques involved in solid modeling for building 3D models is feature-based modeling. This technique refers to the construction of geometries of a product as a combination of form features from a standard library. In this approach, the designer specifies features in engineering terms such as holes, slots, bosses from the feature menu, rather than geometric terms such as circles and boxes. Circles or boxes. See, basically, when you are trying to create a hole, so what we do is we create a circle, then we'll go to extrude, then we'll go to use the subtraction so that we can create a hole from the solid block. But instead of doing that, when you have a feature based, so what is the feature based? Hole is a feature. So what does it again do is you just give the location of the planes of what is the distance of a hole from this plane towards this side, and what is the position of the feature of hole from this reference to this, and then if you just give a hole option, and then whether it is through and through, or whether it can be a blind, or whether it can be a counter bore, all those things features will going to be defined. Once you do that, automatically you are going to get the feature based modeling. That means a block with a hole which can be able to create. But similarly, but other than this, when you want to create by using a non-feature based, then we have to go for a circle command, create a circle of whatever the diameter of the hole which is required. Then you have to extrude that, and we need to place that on the reference point, and then go to subtract from the solid block to that small cylinder what you have created, and thereby you will going to get the feature model. So that is actually the conventional type of modeling, and this is the feature based. Design with predefined form features can reduce the number of input commands substantially. That's what I was discussing about, wherein if you go for a circle, you create a circle, then extrude it, and then go for the subtract and place that particular feature cylinder on the particular location where you want to create a hole, and then go for the subtract, subtract from the solid block, that is the big block, to the smaller material to be removed, and then this is how we will going to get. So by doing so, you will going to get a lot of commands which will going to be used. Suppose if you go for the feature based modeling, just go to a hole option, take the position of the, and it will going to give for the hole diameter, and then what will going to be the thickness what you want. You just specify that and say OK, then automatically it will going to create the hole in a block. So this is how the advantage of the using the feature based command. Then comes in figure A, that is the space where through hole feature is to be selected along with the location by inputting the coordinates or through the mouse. The software program locates the feature in the desired position and subtract from the part model of the cube as shown in the figure B. So this is how you will going to get the whole feature when you are going for the feature based modeling. So then this is the locating the feature here. This is the whole feature what we are trying to create, and this is how, this is the UCS icon which will going to be used. That means where exactly the location of the plane is, that is the one which will going to be shown here, and this is the one which we are talking about, this users coordinate system icon, which is UCS icon. I can move the UCS icon wherever I want in this plane, but only the this thing is, we want to take whichever the reference you want, you can go to that. Suppose I want to create a hole on this particular plane, you just align this UCS icon to this plane, and then whatever you do, the operation it will going to be done on this plane and parallel to this, but it will not be able to do either in these two planes or from the top and bottom. So this is the how this feature based modeling will going to take place. In our next video, we will going to discuss about the parametric modeling. Thank you.